Hey, we got a system. We gotta find the solution of the system of equations. We got y equals x minus 2. We got y equals 3x plus 4. Is 4 2 a solution? That's what we're about to find out, Opties, okay? Hey, you know who it is. It's time to solve this system. I love solving systems. Okay, so we're here at Opto Math, and we're gonna do another video on solutions of systems of equations. So instead of really explaining what a system is, like we did in the graphing video, I'm just going to solve this question. Because this question is asking us if a particular coordinate pair is a solution, this is a much simpler question than just solving for the solution outright. What I mean by that is, if we check to see if this point works for both of these equations, when I say works, it satisfies the equation, meaning if you substitute this x and y into each equation, you'll get a true statement. If that happens for both of those, that means that point is on both the lines and therefore it's the solution. So let's start with this first equation.
All right, hold on, wait. So you're saying you're gonna substitute?
Yes.
All right, so you're gonna do, and what was the previous way that you did it?
In the other video, we used graphing.
Graphing, so we're doing now substitution, okay. And substitution is easier than graphing?
In this situation, definitely, because you're already given the potential solution.
Okay.
You don't have to just find the solution from just the system of equations.
Okay.
You actually get to guess and check with this.
All right,
so this is a guess and check method. So we have y equals x minus 2. So the y value is 2. And that's from this 2 right here. Equals x, which is 4, minus 2. Okay, so 2, does that equal, and I put a question mark over my equal sign if I'm checking to see if something is actually equal. And if we see that 4 minus 2 is in fact 2, so 2 does equal 2. So that means this point is on this line. So we're halfway there. We're living on a prayer. Okay. So we're looking at this second one. Y is 3x plus 4. Now, when we substitute this, if this is also a true equality statement, then the answer will be yes. Okay, so our y value again is 2. And our x value is 4. Okay, so we're checking to see if this 2 is equal to 3 times 4 plus 4. You can already tell without even doing the math that this is definitely not going to be equal, because 3 times 4 is already bigger than 2, and adding more to it is bigger than 2. So it's not true, but we'll go ahead and put the answer.
Also, what I would think, I don't know if this happens in all cases, but after I see the plus sign, I see 4. But unless that was a negative, right? 3 times, unless it was a big, like the numbers were to negative.
Right.
But I would say that every time I see the 4 on the other side, unless the other numbers were negative, I would automatically know that I was wrong.
Yes.
Is that correct?
Exactly, because you already know plus a positive 4 is bigger than 2.
Yeah, because the smallest that I can think of is being 0.
Right.
All right. If I'm not thinking about negative numbers.
Right.
But if it was past negative numbers, like let's say negative 6, or let's say it was negative 2, and then it will be then it will be, the answer will be 2, right?
Yes.
Plus 4. Negative 2 plus 4 is
2. Yeah.
Yeah.
So that's perfect thinking. That's a great way to think about it. So the only way that this could be true for a y value of 2 is that if this 3 times x equaled negative 2. So we see that that's 12 plus 4, which is 16, and 2 does not equal 16. So this is going to be a no. And a yes for this one. But you have to have 2 yeses to make it a yes totally. So it's going to be a no.
All right, we'll check that here in a minute.
Gonna be a no from me. It's gonna be a no from me, dog. That's a dude off of American Idol. Do you remember his name? That judge? He always said, it's gonna be a no from me, dog.
Nope, don't know him.
Yeah, he was hilarious. I loved American Idol back in the day. So no. Let's check. Yay! Awesome, guys. So that was just doing our guess and check with substituting our solution. See ya!